Okay, so this is a problem from Art of Problem Solving's Intro to Number Theory book, and it says it's an old Amy problem. So I'll find where it is and I'll link it. But the question is this: find the smallest multiple of 15 such that every digit is either a 0 or an 8.
Well,
So that's a strange question, right?
yeah.
How do we know that a number like that even exists?
Well, the last digit is going to have to be a 0.
Okay, why?
Because it could only be a 5 or a 0.
How come?
Because it's a multiple of 15.
So why does the last digit have to be either a 5 or a 0?
Because 15 is a multiple of 5. So it has to be divisible by 5.
Okay. All right, awesome. So the last digit has to be a 0.
So 0,
Why can't it be a 5, by the way?
Well, because you don't have 5s.
All the digits have to be either 0s or 8s.
So we have to find the smallest multiple of 15. Well, is 80? Is 80 a multiple of 15? Oh no.
Why not?
75 is.
Okay, 75 is a multiple of 15, but 80 is
Well-
not. How else could we have known that 80 was not a multiple of
By the
15?
divisibility rule for 15.
Which is what?
It has to be divisible by 3 and 5. And it's divisible by 5, but not by 3.
Okay.
Well, what I'd do is I'd look at 30, which is 15 times 2.
Okay.
And then if I could find multiples so if I can multiply 30 by something to get just 8s and 0s, that would work.
That would work. That's going to be you're going to be looking at lots and lots of multiples of 30 though.
Yeah, though, I just noticed something. You have to have a multiple of 3 of 8s. So 3, 6, 9.
Why?
Because this is a multiple of 15.
Okay.
So it has to be divisible by 3.
Has to be divisible by 3. And what's the divisibility rule for 3?
The digits have to sum to be divisible by 3.
Okay.
So we have to make the digit. Well, now we could include 3 8s here.
Okay. Why do we know 2 8s is not going to work?
Because it's 8. Well, because it's 8 times 2.
Which is?
16.
And therefore?
It doesn't work.
Why?
Because the digits sum to be 7.
The digits sum to be 16.
If we have 2 8s, the digits sum to be 16. Why is that a problem?
Because, it's not divisible by 3.
16 is not divisible by 3.
So we have to maybe we can make it the digit sum to 24 by adding another 8.
Okay. So what number do you think would be the smallest
Maybe
multiple of 15?
8, 8, 8, 0.
8, 8, 8, 0.
But this isn't the smallest.
Why not?
Because if you switch this 8 and this 0,
Okay.
you get 8088, which is smaller.
All right.
It doesn't work.
Why not?
Because it doesn't work because you have an 8. It needs to be divisible by 10. Or maybe 5 at
It
least.
has to be divisible by 5. So it has to end in a 0. You're right. 8088 is a 4-digit number that only has 0s and 8s and is smaller than this.
Yeah.
But what's the problem with 8088?
It's not divisible by 15.
It's not divisible by 15. So the question was, make one that's divisible by 15.
This one.
And why can we be pretty sure this is the smallest?
Because you have to end in a 0, so the first digit has to be 0.
You have to end in a 0.
And then you have to sum to a multiple of 3, and there's so you have the digits have to sum to a multiple of 3. So and 8s aren't divisible by 3.
So I need 3 8s.
Yeah.
Okay. Let's go back to our calculator just for speed here.
And so
What do you think? Is this divisible by 15?
Yeah.
Divided by 15, 592.
There you go. So there you go. And that's an 80 problem. That's a tough problem, right?
Yeah.
But it's just looking at divisibility rules, so it's pretty cool. All right. Good work this morning, guys.